Yes, we are recording.
You are.
Yes.
Thank you. So what then happens is the organ of Corti. I want to describe the collier, what it is about. The collier shares the same concept like the keyboard. Like if you realize when you hit your key or your keys on the keyboard, the pitch is different and the sounds is different, and that depends with the strings out there tied inside. So with a collier, you realize that besides it being an organ that transduces your mechanical sound into electrochemical signals that can be understood by the brain, the other thing that it does is sensing the different pitches and the different volumes. Like your area, which is tighter, that region is responsible for the high pitch, and the area that is not that tight is responsible for the dum dum, your lows, your sound transduction. And at the same time, we're also looking into the vestibular apparatus, and the three semicanals that are of interest. You realize that the three semicanals, they are responsible for three-dimensional acceleration, three-dimensional acceleration, your height, your what, that kind of a thing. Then there are the two, the auricle and the forgotten the other, and that has got to do with linear acceleration. So what happens now is what we want to do is to get our sound from the atmosphere to the brain. So from the organ of Corti, that is your collier, there's that collier nerve, and then there's that. Sorry?
Can you hear me? Because generally, maybe I just got a bit lost, but you were telling about the linear acceleration that we can feel it in the inner ear, everything is okay. And then you so smoothly gone to the cochlea that I'm not sure what you meant. You mean that cochlea is related to linear acceleration or not?
No.
Okay.
Like that's vestibular apparatus.
Okay.
The semicanals, those are the ones that are responsible for three-dimensional acceleration. Then there's one called auricle, which is responsible for a linear acceleration, which is found on the vestibular apparatus.
Good. Everything's good. Just it was so smooth that okay.
Okay, so now back to the like I'm now done with the inner ear. What I'm doing now is moving on to the brain, like how the sound is then transduced from the inner ear to the brain, auditory area of the brain.
Okay, I suppose it's enough about this. I already see that you know. Okay, I will just ask you one more question, just to be fair. So, what to ask you? Okay, tell me about the SA and AV node.
The what?
SA and AV node.
Oh, SA and AV node. Okay, in the SA and AV node, like you are talking about the heart, right?
Yes.
Okay, fine, that's okay. What the SA node is found in the, well, let me see, this is so this is the right, left, the right atrium, and what it is responsible for. It is responsible for pace setting your electric impulses, and it's found within the myocardium of the heart, which is responsible for electrical signals. And then you find that your left ventricle and rather, let's say the left side of the heart and the right side of the heart is separated by the membrane, and that on that membrane, that's where you find the AV node, and it is known as the collecting node that collects impulses that are generated by the SN node.
Yeah, very good. Okay, so just to be, you told about this collecting. Why? So from my mechanical perspective, why this stoppage why this collecting and processing, so stoppage of the signal in the atrioventricular node is important?
Oh, it is important in the sense that you realize that what we want, like we have our pulmonary circulation, our circulation, and then there's the systemic circulation. Then what happens is like our valves are sort of arranged like within the same plane. But what we want is for the atrium to receive blood, your right atrium and your left atrium to receive blood at the same time. But what we don't want a situation whereby the ventricles are also pumping blood at the same time. So what happens is that your valves, they do not conduct electricity. They are insulators. So what happens is that they cut the moment blood reaches the valves, they cut the impulses. So what we want to do is the AV node then collects the impulses so as to relay them down to the apex of the heart to cause the contractions that we need to pump the blood outside of the heart.
Okay. Yes, this is true. This is true. So generally, as you said, the AV node is physiologically, at least, the only point where the electricity can get through between atria and ventricles. Okay, yeah. There's also one more thing that generally, in order to give time for atria to contract, the AV node needs to stop this electricity for a moment. Yes. So it's not only distributing it; it's also stopping it in order to give the atria time. But okay. I do not think I need to ask you more. I would give you 5 for physiology. Now genetics.
Thank you, sir. It's done.
Okay.
How was I?
Congratulations.
Thank you so much. I'm happy. Wow.
Thank you.
Have a pleasant night.
Okay, so have a nice evening, have a nice night, and generally remember to fill this Google form that is on the Google Classroom, okay?
Okay. Thank you so much.
Oh, you want genetics now or it later?
Genetics, I haven't taken that one. So
okay.
I'll talk to you once I'm ready.
Okay, of course. So one more time, congratulations.
Sir, is it possible to share with me the audio?
Audio? Yes, generally in a moment. Wait a moment.
Okay. Thank you so much, sir.
Wait.